Okay, so this first recording will be on chapter 8, but we'll hopefully get into chapter 9 if we have enough time today. Okay, so chapter 8 is all about planning, or the planning process, and the way that the thinking plan that we're going through. So we'll see on page 130, there's a couple of things that Cook just highlights. I think I've highlighted this before, is fail to plan is planning to fail. So that's probably the most important thing to remember whenever you do planning, is to actually sit down and do some planning. For instance, now for studying and your bottleneck for this test and stuff, it's all becoming now a reality. But if you sat down, you would have been accustomed to it already. So you kind of know about it already. But I'm sure you guys did have a look at least and have an idea. Yes, this time of year will be a bit of a bottleneck. So that's what that basically means, is just to sit down and actually plan. Okay, so a couple of questions. Why do we plan? To set a realistic time frame, realistic standards, aid in the control. That's what we're actually working towards, is control. So you'll see that's how the subject is structured as well. So we're looking at project planning now, and then we're getting to the actual control bit. But if we didn't do the planning, you can't do control. Okay, then monitor of performance in time, money, and output. And then we've got the review process in progress as well. Okay, then I just added, or I've you'll see the next slide looks at, or this little table that they give is from the CIOB. I've also incorporated the CIDB's guide to planning a little bit later. But basically, table 8.1 just lists the type of planning processes or scheduling methods that we've got. So I've spoken about master programming, the master program before, but the CIOB basically divides scheduling into design, or your pre-tender program. Then you have a pre-contract program, which is your master program. That's the one that you usually get from the contractor when you ask for tenders and so on. No, not what you get from the contractor, but what you, before, when you go out on tender, which you already have drawn up. So your construction will just be a one-liner. We want to start this time and we want to finish that time, and then the contractor submits a tender program based on that timeline. Okay, then we've got target programs, subcontractor programs, and procurement programs. So these three last ones is the ones that the contractor actually draws up, and then we get to the contract one. So we have a stage program, the short-term program, and then we've got the as-built program. And I think the as-built program speaks for itself. That's the stage program that you receive from a contractor, just kept up to date if there's extensions, if we ahead of time. So that's the one that fluctuates, and the construction process is monitored against that one. Okay, then the SACP CMPs schedule I just included as well. So remember, this is the 6 stages that we've discussed in Unit 2 and 1 as well, where we've got the inception, concept, viability, design, development, the documentation, procurement, and then the construction, and then the construction layout, or the closeout. Okay, then your project master schedule. So this is very important for me. You must know what the master schedule is. The time scale is given in years rather than weeks. The use of negative time to indicate the pre-construction time. This is not that important. The second point, what it basically says is that you may indicate a negative time before or pre-construction. That's solely up for preference. I usually don't do it because it does confuse. It's confusing, and plus the other thing is there's no need for that really. All the programs work quite fine if you just work from a start of your design and add in your time accordingly. Okay, obviously your holiday periods are included. Your milestones are included. Your milestones are specific milestones. For instance, your tender document will be finished by this date. Your contractor will be appointed by this date. The site will be established by this time. The practical completion will be at this time. So that's basically what the milestones are. Okay, emphasis are on the client's team. Then the construction is given as a single line. You have a start date and handover in the appendix. The appendix is appendix to your contract. Basically, you just list this is the start time, this is the handover time. And then you have intermittent activities that show with, which is shown with a dotted line. Yes?
That construction equals single line, what does that mean?
That basically I'll show you now with the example. That's what it means. The construction period is just given as one line. Yeah, at the bottom. There's no breakdown of site establishment, foundations, your upper structure or your low structure, upper structure, etc. So it's solely one line, and this is now the consultants basically saying, okay, it's if it's for instance a 3 million rand worth of project, a contractor of this size might be able to spend about 500,000 per month, or claim 500,000 per month. So thus he will need about 6 months to complete this project, and that's basically that one line, and that's calculated like that. Okay, so it comes with a bit of a sum suck and a bit of experience to actually calculate that type of thing. So this is an example of that master program. So you will see what type of items are listed here. So you've got the point, project manager, consultants, developer strategic brief, you have health and safety file, concept design. This is something that we will discuss later on. This is how it's supposed to work. Usually the health and safety consultant is only appointed like tender document, and then suddenly, okay, we need a spec, and let's phone a friend and get a spec quickly and slot it into our tender document. I've got a tender that's going exactly that way now, because the clients don't really realize how important it is to get your health and safety consultant appointed from the get-go, and it's actually law. The 2014 construction regulation says you have to have a health and safety professional appointed to do a baseline risk assessment and to assist with your design health and safety assessment as well. So that's something that you guys need to know, and it's usually difficult to bring that home to the clients because it does carry a bit of extra cost. Okay. Planning and approvals, obviously the design has to go through those different stages that we've spoken about: approvals, going back, amending cost estimates, seeing, checking whether it's actually fitting in. Then you've got schemes, then you've got your detailed design, health and safety plan is updated. Then you've got your tender phase, your tender procedure. If everything does go well, within the next 3 weeks we'll actually have a site tender briefing that I'll take you guys to. Exactly this project that I'm talking about now. So we're quite lucky to actually be able to go to a site briefing like that. Okay. And then we've got the construction phase, which is just 2-liners, basically your construction period and your handover, and then your occupation. Sometimes what I just add here is your closeout as well, depending on your defects liability period, that 3 months or that 360 or a 1 year period. So that's just something that I usually add. Okay, this is one that we did for a tender. So you can see it looks exactly like that. We've got our report stage, preliminary design stage, um, and then we've got our design stage and tender stage, and then we've got the construction stage here. And then what we just did here is some milestones that the client was looking for, the different outcomes, completion and submission reports. So this specific client, this was for Department of Health that we did this tender for, or this program for approval. And so you can see this is very basic master program. Okay, then Cook and William continues to talk about lead times. This is where your planning process comes in to think about lead times, ample lead times from time of design or from your design stage to ordering the materials. Not all materials are off the shelf. That's usually what prolongs a project. Is, for instance, if you've got a mechanical installation and the air cons have to be imported from somewhere, that can have a bit of an effect on your program. So you have to phone or plan for these items. Obviously, off-site manufacturing you need to think of, and then also commissioning. The example that I've got here is the Gautrain. The Gautrain had to be finished 8 months before the first, or 6 months before the actual first commuters could actually go onto it because of the safety tests and regulations that they had to go through. I think the trains had to clock a certain amount of hours before the public were allowed to actually go onto them. So that type of lead times you need to think about. Okay, so that's the fun bit. That's the scientific thing. Prof. Vasi used to say that's why it's a BSc course, is because we think or we plan and we basically create a theory of how much this project will cost and how much time it's going to be that we're going to use, and then we actually test it. We test that hypothesis of how long this project will actually be. So if you think about it like that way, it can be quite interesting and yeah, fun. Okay, then you can go further and you can have work breakdown structure. It's almost the same as your milestones, but your work breakdown structure is more specific. Your work breakdown structure captures the scope and it breaks it down into different chunks. For instance, I have to order the material by this date, otherwise I won't be able to complete this task within time because it's going to be delivered too late. So your work breakdown structure captures the scope and breaks it into manageable and smaller chunks. Then Berg suggests that the different levels be used. This is illustrated in figure 8.2, so we'll have a look at that now. Most software aids in the compilation of a work breakdown structure. Basically, this is how your work breakdown structure looks. You've got your project, which is level 1 or level 0, and you've got your different items below that. So you've got your substructure, superstructure, and your finishes, and then you basically just go and break it down into smaller chunks, manageable chunks. And you can go to multiple levels actually to this team actually will do this bit of tiling of this corridor on the western side. So you can actually go into very much detail of that. For instance, what they highlighted here is level 2 elements may be further subdivided as required. You've got your excavate your pile caps, cut off or trim the piles, blinding, base or pile caps, fix formwork and base, and fix steel reinforcement, set bolts, place concrete, strip formwork, and backfill working space. Okay, so that's basically just going through it and sequencing it. Heinrich, have you been to that site there across from the SARS building? That one for Sky Construction? Not yet.
I think don't we wanna go there?
But that's why they're building the new shops.
Yeah, that's just across from that.
Okay.
Yeah, that's
Are we
it.
going on a site visit there next Tuesday?
Yes, that's the one that Dr. Ramoa is going
Yes.
to. Yeah, yeah, I've organized that one for him.
Okay.
But the other one on the other side, Sky Construction's site,
Yeah.
I think that one will have piles, but I don't know how far they are with the piles. They might have closed it. But basically, do you guys know how piles works?
Don't really focus
Okay.
much.
Basically, how piles work. I'm just gonna. Okay, so that's how the piles work. And then getting to your planning your stages, Cook just highlights you. This is very important for me. Is you have to apply your mind, and this is where experience comes in. You have to visualize yourself how you actually going to build this building. That's why QSs usually make very good um, project managers, or if you have a QS background, because you have to envisage yourself when you're doing the measurements of how that thing is actually fitting together. So that's what the construction managers actually what their forte is to visualize what is going to happen on site. That's where you need to go to, is you need to apply your mind um, whenever you do your planning. So you need to apply your mind. Project planning by a client is done by the client or project manager. Here we go. And then pre-tender by the contractor, and a pre-contract by the main contractor. Then you have the contract planning, contractor, and subcontractors. So please have a look at figure 8.3. This is for me, this is an important figure that actually explains how the project planning is done and the purpose of the design stage and of each one.
Van meneer van soos vra om soos daai hele ding te teken of
Yeah, but I'll ask you, rather ask you what, as a discussion, this will be a good mind map to actually discuss what I'm asking. So, yeah, but if you can draw this, you can discuss it as well. And obviously, if I do ask a discussion question, if you can draw this, it will help you in your discussion and your explanation as well. Yeah. Okay, then we get to project planning. This is done between the client and his professional team. Usually it starts at stage 1 of the project and it continues further on. Items that are looked at is the key dates for commencement and completion date of the project, key dates of design, tender and construction, overall program phasing, design and tendering periods, key dates and commencement of completion and construction, stage or phased handovers. Okay, the reason for this stage planning includes we need to get to a realistic master program. It doesn't help. We had a client who used to try and push the envelope, and he would use to set. He used to set unrealistic time frames for everything to happen. So I think in the end we did get things done quicker because everyone was on edge the whole time to get the stuff done. But still, it caused some animosity between some of the role players, and it was quite stressful actually doing that. And it's not necessary to do that. If you do proper planning, you have to consider lead times. For instance, lead time from your architect, from actual design to approvals of your client, and so forth. So you can. The main thing is to be as close as possible to that. The same thing applies when you do your estimate. When you do your estimate, you want to be as accurate as possible, um, so that you can actually do proper planning on it. Okay. Then identify your key dates. That's the next item. You need to facilitate and control your items in the end. It should be controllable. Identify potential risks. That's why we do planning. And then the client financials is important. realistic time periods for construction is to be set. Okay, so that relates to the first item. And then monitor actual progress on site. All of this is just to be able to actually be realistic about what the progress should be on site. Okay. Okay, pre-tender planning, the contractor does this to get a realistic contract period, construction methods, to get an accurate bid price, P's and G's, tendering processes. It's this bid price, you have to do a pre-construction method statement to see, okay, I need this, I'm going to need a crane, for instance, to do this job, and I'm going to need it by, within this period of the project. Or, okay, no, I can't use the crane only once, I need a crane twice, a mobile crane perhaps. So at the start of the project, I'll maybe use it once, and then in the middle or later on. So that's what the things that influence your bid price. So you need to schedule to be able to get the holistic picture of what's actually needed on site. Then obviously that influences your P's and G's. For instance, if your master program says, okay, you need to be finished within 6 months, and you do your calculation and you see, no, we're not going to be able to do this in 6 months. We'll only be able to do it in 8 months. Then you have to take that into consideration when you submit your project. Or your bid price, or it can be the reverse of it. You might be able to do this project in 5 months, and then you can actually work out, okay, I can get a competitive edge by doing it quicker on my fellow contractor, so I'm going to price my P's and G's lower because of that, and get that competitive edge. Okay. If it's longer, you include a bit more, or you price only up to that month, and you qualify that within your tender document. And then you tender process. Okay, obviously you need to know how long the tender will take, and then also how long when you might be appointed. The rates may have gone up or not, so you have a bit of inflation built into that as well. And then in the overview of the contractor's planning process, again, this is very important for me. So please go through this diagram. It also involves your pre-tender planning, your pre-contract planning, and then your contract planning. So you will see everything is basically divided into your 3 sections. Your pre-tender planning, your pre-contract planning, and then your actual contract planning. Okay. Your pre-contract planning includes after contract award, documentation of the works. So this is after you've been appointed. Now there's a whole lot of planning that actually starts. So you've done the preliminary design and programming, or not design, but programming. Now suddenly you're awarded it. So usually you get notice you have to be on site within 2 weeks, or you have to be on site within a month. Or so, and within that time you have to do a lot of planning. You might have a handover meeting from your consultants to actually transfer the information from them to you, and that type of thing. You need to draw up your health and safety plan, your program, etc. The one contract asked for within a certain amount of time, that's what I just talked about. It's basically the compressed master program that you need to look at. The reason for this program is a broad outline plan of the strategy. You have to comply with the contract conditions. The contract asks for that. Establish a construction sequence, highlight key information needed, when, and budget and cash flows obviously goes with that also. Key dates for ordering of material is set within this time period. Okay, so just to comply to contract conditions, for instance, a GCC, Within the GCC contract, it's default that you have to supply a resource-based program, whereas the JBCC doesn't specify how your program should look. It just specifies that the contract should actually, or your program should actually, you just have to have a program by your site handover. So that's the differences. So some of the contracts may ask for more details than others. So please take note of that. Although, for instance, JBCC contracts, we usually amend it to actually look the same as the GCC with your program. So whenever you do a tender, just have a look at or ask what they're actually requiring. Okay, then your contract planning. This is now your actual contract when you start. It's a master program in more detail, or it can be compressed more into smaller short-term programs. It includes your as-built program due to extensions, etc. And the reasons for this program is to monitor the master program, plan site operations, optimize and review your resources, and review the project and report variances. Okay, so it's basically for control. Then planning a project has a few sequences. It should be realistic. You feed off your experience. The computer software is only a tool, but it can aid you a lot whenever you do your planning. For instance, our site foreman that worked here on the media project, he only started on the project quite late, but he worked on the, now I'm thinking, what's that sailboat in Dubai, that hotel, I can't remember what that, yeah, but he's here. But anyway, he worked on that project, yeah, it's also a birch something project, I can't get onto the name as well, but he worked on that project, and he said that program for that project was done by hand. It wasn't done on a computer program. It was actually done up by a guy drawing it by hand, and the schedule and everything by hand. And he said they were on time. Everything was up on time. But the main thing that he said, the difference is he had to know what each item influence on how the whole project's integration worked. So that's something that falls away whenever you use a computer program. Okay. Okay, so I just included something additional for us. For instance, if you've guys heard about BIM, so I just included the Gartner hype circle, and everyone is so excited about BIM, but it's a new, like any new technology, it promises quite a lot of, or it creates a whole lot of expectations, but once you actually start going through or trying to implement it, you can get to a trough of disillusionment, because it's not a holy grail, this new technology or technologies that you get, but it is an improvement. So you get to this trough of disillusionment, and then you gradually start using the new technology, and it actually gets into a situation where you actually get the benefit of that new technology. I think we're currently with BIM in South Africa, we're more or less here, maybe just coming out of it, where everything, I think the architects are here already, or maybe proficient, but the information that they give to the construction managers and the QSs isn't always up to date. So we can't really use that information to draw up goals and to draw up schedules just yet. But okay, then I just added something extra. These sweeping technologies changes will effectively change the skill sets of the future workforce, as well as the approach to work in general. As a result, societies around the world will need to consider how to make the most of these new opportunities, and thus ensure that they remain competitive in the global marketplace. So this is just an added item whenever you guys think about having a competitive edge over the rest of the guys is do what works, but do not exclude new technologies. New technologies are implemented slowly. Don't think it's a holy grail and go to that and not understand the underlying principles. Okay, the main thing is to get the feel of the project. You have to study the drawings. You have to visit the site. You have to assess the scale and scope of the project. You have to assess the approximate value of the project, and you have to consider the rate of the expenditure, and you have to apply your mind. That's the main thing, is common sense. It becomes common sense certain areas as you get more experience through, to plan a project. Okay, you have to establish the key project dates. Key dates is the project start and end, sectional or phased completion, holiday periods, commissioning, and a handover. You need to know when the start is, intermediate, and finish. Cool. Okay, then other key events include activities or tasks or jobs which have time value. Cook and William has a certain checklist. Now this checklist, let me just see where that checklist is. This checklist is very important. I didn't. 140.
41 is the checklist of key activities against during the construction stage.
Yes, yeah.
Oh, so page 141.
Yeah, so those, this is quite key for me.
During the construction stage or all the stages?
Basically all the stages.
Basically.
Yeah. Because this is what you will use during, it's important when you get into practice. This is something that you will use. Whenever you get onto site and you're green, this is your checklist. Brief the design team. Make the professional appointments. Notify the project to the health and safety executive. Do not skip that point. Do not pass beginning. Do not collect your 200 rand. That type of thing. Okay, start the health and safety file, obtain planning permissions, etc. So, assessing how long the activities will take. Okay, so please go through that checklist. And basically what you calculate is the quantity and then the output per hour to actually calculate how much hours you will need. So this is very simplified, a resource-based planning process that we go through. Days, number of days per week, you actually calculate how much hours you need, and then the hours divided by the days to actually get the number of days that you will need for the project. Okay, and that's chapter 8.